this video will talk about osmotic pressure. Okay, and then for this particular question, actually, we don't really need to quantify the information because the question didn't ask for us a final and in the terms of detailed value, but asked us to compare two solutions about their osmotic pressure. Okay, so now let's read it real quick. Okay, so we asking between this solution, okay, and this one. So you have 1 gram of sodium chloride in 10 of water, and you have 1 gram of cesium bromide in 10 m of water. Okay, so then we have to quickly recall what osmotic pressure was this about. Okay, so of course, right, right, we can bring the equation. Okay, so osmotic pressure pi equals to I, which refers to Van Hoff's factor, molarity times R times T, right? Okay, so this is the equation. Now let's see from this equation how it relates to our question. Okay, so the question is asking you which one has higher osmotic pressure. So we're comparing pi. So then let's see about the rest term included in this question. Van Hoff's factor, right? This is about our solute. Okay, so in both solution we have sodium chloride and cesium bromide. Okay, so what's their Van Hoff factor? What does I equals to? Okay, so as we said, I relates to electrolytes, okay, and then sodium chloride and cesium bromide. They are both soluble in water, which means they're gonna from one unit compound unit will be dissociated into two particles. Okay, so then therefore the I Van Hoff factor will equals to 2 for both solutions. Okay, so then we'll have actually same I Van Hoff factor for both solutions. Okay, so that's good to know. Now let's see the next one. Okay, so next we need to compare their molarity. Okay, so now let's try to recall how to calculate molarity. Okay, molarity is not molality. Molality is lowercase m. Molarity is capital M. How do I calculate it? Most of my solute over liter of solution. Okay, so now liter of solution, we have 10 ml water, 10 ml water, right? Okay, so the volume for both solutions is the same, even though it's not in liter, but we can clearly tell they're the same. Okay, so this is the same. In order to find higher osmotic pressure, which means we can look for higher concentration, higher molarity, okay? So which means we need larger moles of the solute particles, right? Okay, so that makes sense, right? Okay, so but let's keep on reading, see what about the rest, okay? So the rest we have what? R, right? That's a constant. Of course, for both solution, R value will be the same temperature, even though the question didn't specifically mention a temperature, but we know, right? These two solutions we're talking about prepared under this similar situation, okay? So then temperature should be the same. So now comes to back the conclusion we were talking about earlier. Yes, in order to look for a higher osmotic pressure, right, equally saying, or now this is your turn into, we're looking for higher molarity. Okay, higher molarity, since they have the same volume, really we're looking for what? Higher moles, larger moles from both solution of the solute particles. Okay, so now how do we calculate moles? That turns into the follow-up question from this point. Okay, so how do we calculate moles? I'm gonna turn over here. Okay, so then we see the question giving us grams. So from grams to moles, what do we do, right? So let's see moles of certain substance, right? What do we need? We need the mass. Of course, can be in grams divided by the molar mass. Okay, so if we're looking for larger moles, mass-wise, for both solution, we have both is 1 gram and 1 gram. So then that's the same amount, right? Okay, so then really, if we want to look for large moles, what do we need? This is a mathematical relationship. So what do we need? We need a smaller molar mass. Okay, so you're really looking for a smaller molar mass between these two substances, one sodium chloride, one cesium bromide. And then as I said, you really don't need to do the calculation, go to periodic table, right? We can see the trend, right? So based on the locations of both substances from the periodic table, then we know, or we can tell which one has a smaller molar mass. Of course, sodium chloride will have smaller, right? Sodium chloride actually has a smaller molar mass, leading to larger moles. Okay, larger moles leading us to higher molarity. Higher molarity relates to the higher osmotic pressure under the conditions we're discussing in this question. Okay, and then hopefully this is helpful, and thank you for watching.